You've just turned in homework number 7, so it follows that next is homework 8. I've got that assignment finalized, but I haven't yet posted it on Blackboard. I'll do it after class, so look for that posted on Blackboard this afternoon. It's due Monday of next week. And then the other thing besides homework 8 that you should be spending a little bit of time thinking about and working on is the project. And I'll remind you that Wednesday of last week when we had the recorded lecture, there's about a 20-minute segment on that lecture video at the end where I go through and illustrate a couple of hints that may make the project quite a bit easier for you to solve. If you're looking for a way to get started, then have a look at last Wednesday's video. So today we're going to continue talking about incremental analysis, and we touched on this Friday in just discussing what the increment is. So any questions about the announcements before we do some incremental rate of return analysis? All right. So we looked at this slide last time, and the idea being that if we have two options, then the increment is the difference between them. And that's one of the key ideas of economic analysis for engineering projects, is that when you're comparing alternatives, you focus on the differences, not on the ways in which alternatives are the same. And so in this case, the differences are the price. And just for simplicity's sake, what we're going to assume is that for all of the analyses that we do today, the alternatives can achieve roughly the same goal, although they may generate different levels of profitability. And that'll be given to us in the problem statement if they have different costs and different revenues that they're able to generate. So the increment is the more expensive option minus the less expensive option. And so if we wanted to analyze the increment, then there will be some incremental cost between the two. So option B being $60,000, option A is $40,000. So the difference is that the more expensive option is $20,000 more, and then it has these added benefits of reduced cost for operating expenses each year and an improved salvage value. Do you have a question? Okay. So this is just to recap what we'd already talked about last week. Now, we're getting to the point in the semester where there are a lot of variables and different terminology, and some of it may be overlapping in your mind, especially because the letter I is used so many different ways in this course. And so I thought just briefly what I do is revisit, differentiate some of the terminology and variables just to make sure they're all on the same page. So the capital I means the interest amount. And so this could be how much you've earned or how much you have to pay over time based on the initial amount that was borrowed or loaned, and then an interest rate. But the capital I isn't referring to a percentage. It's referring to an amount, meaning how many dollars. Lowercase I is when that amount is expressed as a rate or as a percentage of the original amount per time period. And very often interest rates are expressed on an annual basis, but sometimes when we have problems where compounding occurs multiple times per year, we have to calculate the interest rate per period. So lowercase I is interest rate, just general. Now, lowercase I with a star next to it means the rate of return, and we've talked about unrecovered investment balances, and we've talked about how there is an equilibrium between inflows and outflows. The rate of return is when you assume that the earnings are being reinvested back into the project, and the internal rate of return is one specialized subtype of rate of return. But it's different than the interest rate, because what we're doing with this I star is trying to find zero balance at the end of some study period. Whereas there can be loans which are perpetual, and there isn't a defined study period, and so you could have an interest rate without having a study period defined. I star is talking about the equilibrium between inflows and outflows over some certain fixed period of time. Okay, now I prime refers to the external rate of return. And of course, this is different from the internal rate of return because there are a lot of projects where the profits that are generated can't be reinvested back into the original investment. So there has to be some external reinvestment rate. So the external rate of return, I prime, is a weighted average that takes into account not only the rate that profits are generated, but also the rate of return earned on where those profits are put after they're generated. And that external reinvestment rate is I sub I. That's a given in external rate of return problems. That's the known rate of return that's earned by the profits when you put them somewhere else. That I sub I is what you use to discount the outflows to the present and compound the inflows to the future as one of those preliminary steps in calculating the external rate of return. All right. Now last is something that we're going to be talking about today, delta I star. So delta is just another symbol to represent increment. It means the difference between alternatives. So oftentimes what we'll want to do is calculate what is the rate of return on the additional money required for a more expensive alternative. So that's what we're fixing on today is the internal rate of return. On the rate of return on the increment. Okay, so just as an illustration, we have two options in this setup. Option B costs $73,000 for the initial acquisition. Option A is $60,000. So you can see that the added cost between the alternatives is $13,000 at year 0. And then what you get for that additional investment is an extra $4,225 in revenue each year. Now the question is, should we go for option A or should we go for option B on the basis of this incremental analysis? So our MAR is 10%, the minimum attractive rate of return. And the decision criteria that will apply in incremental rate of return analysis is we'll calculate the internal rate of return on the increment, meaning on the difference between the two options. And if the rate of return on the difference is greater than or equal to the MAR, then the additional investment is justified, meaning if the additional investment is justified, go for the more expensive option. So let me illustrate on Excel how we would do this analysis. And you can follow along if you like, or you can just watch because you will be getting some practice in just a moment. Let me just paste the table as it's given into Excel. All right. And what we know here is that the MAR, minimum attractive rate of return, is 10%, so 0.1. Let me zoom in a little bit to make this easier for you to see in the back. I know sometimes this is hard to read, so if you find it tricky to see the screen, there are always open seats on the front row. Okay, so we could do initial screening just to see, like, are both of these options justified? So initial screening with IRR. That's the first thing I, maybe just as a matter of habit, am going to do. So IRR. 17% for option A, and option B 16.3%. So the conclusion of the initial screening is that both are acceptable. Neither one of these options should just be rejected outright. Both of them seem okay. Like, we're not going to lose money on undertaking these projects if the MAR is 10%, and both of them make more than 10%. But the question is, which one should we do? And we've already learned that you can't just pick the one with the highest IRR. And who can revisit why that is? Why is it that you shouldn't pick the best option merely on the basis of which alternative has the highest IRR?
Because like the cost may be different and it may like...
It's because of the initial cost difference. Yeah. Remember, when I first introduced this idea, what I said is it would be better to earn 5% interest on an account that will take $100,000 compared to 6% interest on an account that will only take $5,000. You know, if you can only pick one investment or the other, it may be better to maximize the total profit that you earn, to have a lower rate of return, but a greater amount of money under investment. Okay, so all we do with this IRR is the initial screening. So B and A are both valid options. So now what I'm going to do is I'm going to find the difference between the two. So just because I want to put the symbol in there, let me go here to Greek. Let's see if I can find the Greek symbols. This isn't where, there we go, Greek, and then I'm looking for delta. All right, so delta between B versus A. I'm not sure why that's so big there. Basically, let me just call this B minus A. All right, so it's option B minus option A. So 13,000 extra in cost at time zero, 42.25 in added revenue. Now I'm going to calculate the IRR of the increment. So IRR of the increment. Now remember, when I use the IRR function, what it's doing is it's finding what interest rate brings equilibrium between the inflows and the outflows. So it's discounting all of that future revenue at some unknown interest rate until it finds out what interest rate would it be that makes all of this future revenue equal to the present cost required to initiate the project. So it's in the background doing that same thing that sometimes we've done using GoalSeek. So it's calculating the internal rate of return here. It says 11.4%. Okay, so what's our conclusion here? Let's revisit what is the decision criteria. If the IRR of the difference between two alternatives is greater than or equal to the MAR, then the additional investment is justified. Okay, so since the IRR of the increment is greater than 10%, which is the MAR, then we should select the more expensive alternative. So choose option B. So this is another one of those cases where if all you did was just pick the one with the highest IRR, you'd get the wrong answer. You should pick the one that maximizes your profits. Now, how do we know that option B will maximize the profit? Because just think of it this way. The extra $13,000 that you are spending to get option B, that extra $13,000 is yielding a return of 11.4%. Your minimum attractive rate of return is 10%. So if you could borrow money at 10%, and put it somewhere that yields 11.4%, you should do that. Like if you could go to one bank and borrow money at 10%, then go next door to the other bank, put it into a deposit, and that deposit pays 11.4%, you should definitely take that deal. So that's basically what this incremental analysis is saying is, are you making more or less than what you consider the minimum attractive rate of return for this original investment? Any questions so far? What would be another way that we could prove to ourselves whether option B or option A is more profitable besides the incremental analysis? Okay. I don't know if the IRR analysis would tell us option B versus option A. Because the IRR analysis already takes into account the initial purchase price. So it's not like we've neglected that. But present worth analysis is always going to give you the right answer. Like if we do present worth analysis to find out what's the net present value of option B, what's the net present value of option A, then what we would want to do is choose the alternative that has the highest net present value. So remember that there's this function called NPV. The NPV function, we haven't used it in a while, but let me remind you, when you say NPV, what you need to do is give it the interest rate that applies, and in this case it's 10%. And then what values should you put into the NPV function? There's kind of a warning here. Anybody remember the caution or the warning you should use when applying the NPV function?
Don't use the value of year zero.
Exactly right. Don't use the amount that's already at the present, because what the NPV function is doing is it's converting future amounts into a present amount. So the first amount that it wants to see is how much was it in year one. So we would do the NPV function by using this data, years 1 through 4, and then outside of the NPV function, we would add the amount that's already at the present. So the big warning with NPV, and sadly it's something I have to take points off for in exams occasionally, is don't include the present amount in the NPV function, because it's a conversion function. You don't put amounts that's already at the present into that function. So if you did option A, and let's say you had to borrow the money to purchase the item, and you were paying 10% interest, all of this revenue discounted to the present and taking into account the interest payments on the original purchase, you'd still have some money left over. You'd have $97.37 left over if you initiated this project. Option A. Option B, I can just drag this to the side and it'll apply the same NPV function to the next column. Option B yields more money. So which of those two options is more attractive? According to present worth analysis, option B yields the most profit. Option B is the most profitable, both according to present worth analysis and also incremental analysis. So there will never be a conflict between the two. Present worth analysis will tell you which option is best. Incremental analysis will tell you which option is best, but they answer different questions. The incremental analysis tells you what's the rate of return on the extra amount you're spending between the two alternatives. So if your boss says, well, why don't we just buy option A? It's the cheaper of the two and it gives us a profitable project. The way that you could answer the question, why don't we just purchase option A? The way you could say, well, we should go for option B is the extra $13,000 it costs to buy option B instead of option A will yield a rate of return that's greater than the minimum attractive rate of return. All right, so we've looked at this scenario from two different angles, from the incremental rate of return analysis angle, which is mainly the focus of today. But I just wanted to do this quick proof that we'll get the same answer if we analyze the alternatives using present worth analysis. So any questions about that? Decision criteria. Hopefully that phrase is burned into your memory. You should know the decision criteria for every type of analysis that we do. External rate of return analysis, internal rate of return analysis, future worth analysis. This week we're going to do benefit cost analysis. Next week we'll learn cost effectiveness analysis. All these different methods that you will learn for analyzing options. You should always know what is the rule for how you make a decision afterwards. It's not enough just to calculate the values, but there has to be a statement of how to act. You know, what should you do based on this analysis? So choose option B is the statement of action, and the decision criteria support is that the incremental IRR was greater than the MAR. So you need to pay special attention to these decision criteria statements. Okay, now the option that I just, scenario I just shared with you only had two options, option B and option A. What if you have many different options? What I want to show you is the process that you go through, because we're not going to compare every single option to every other option. Like, how many potential matchups could there be? Well, if there's 1, 2, 3, 4, 5 options, then the number of like paired alternatives could be 5 factorial. But it's not that many matchups we need to do, because there's going to be a special order that we perform the analysis. And so if you have a series of alternatives, remember that the first thing you do is you put them in order. So cheapest on the left, most expensive on the right. I'm going to give you an example today. I'm holding it up right now. It's not in order. I did that intentionally. I put it out of order so that you would have to practice putting it in order of cheapest on the left, most expensive on the right, and gradually increasing. So the first analysis that you do down here at the bottom is initial screening with the incremental rate of return. So you can see here up at the top it says that the MAR is 18%. And if the MAR is 18%, every one of these has an internal rate of return that's greater than that. So we're not going to throw out any of these options, but in the in-class exercise that I'm going to give you in a moment, you are going to reject at least one of these alternatives. At least one of them won't pass the initial screening. And so if it doesn't pass the initial screening, then you don't have to do an incremental analysis. It just gets rejected at the outset, and you're not going to continue on after that with these 1 versus 1 matchups. So the first matchup that we're going to do is option B versus option A. Because if option A is acceptable, and it is, and it's the cheapest, it is kind of like our default champion at this point. Without any other comparisons, option A is kind of my go-to alternative before we begin the incremental analysis, because it's cheapest. So the first matchup is B versus A. So I make a column of B versus A. So the incremental cost is $12,000. The incremental revenue each year is $3,100. And then I'll calculate the rate of return on the increment, meaning on the difference between B versus A. So if the rate of return on the increment is 22% and my minimum is 18, then the decision criteria says accept the more expensive alternative. So B wins that matchup. A was acceptable, but B is better. So my next comparison is going to be C versus B. I don't have to do a comparison of C versus A because A has already been replaced. In the matchup of B versus A, B was the victor of that comparison. So the next matchup is C versus B. So the increment is the cost of option C minus the cost of option B. So I'll find the incremental cost, the incremental revenue. The rate of return on the increment is 43%. That's greater than the MAR. So that leads me to believe that I should choose option C. Okay, so option C is the next kind of the current champion. So the next alternative that I compare it to would be D versus C. So you can see here I did D versus C. It had a rate of return of 0. So that's no good. I reject alternative D, and so the final comparison is not E versus D because D has been rejected. The last column that you can see here is E versus C because C won the matchup of C versus D. So the idea is that you're only doing one at a time, and you don't necessarily know what all of the incremental analyses are going to be. You don't know what to do after B versus A until you know which alternative wins that matchup. So it could have been that the next one that I did, maybe it would have been C versus A. Maybe it's C versus B. But you don't know until you reach the conclusion of each increment's analysis. So you wouldn't do all of these, you wouldn't set up all of the incremental analysis at once. You'd do them one at a time, and then you'd know the next one to do afterwards. So the final answer here is option C is the best, because it was the one that won the final matchup of E versus C. The rate of return was just 14%. So if it's only 14%, then option C is the best, because that was too low, is below 18%. Okay, let me give you this handout so we can get started on this one. We've got several different options, and you can see in what's on the screen there, I've referred to these by, like, the letter of the option is in bold. Please don't rename them. Don't name them like A, B, C, D. That'll make things confusing when I show you the answer. Just refer to them with the letter that's in bold there. Any extra papers? By the way, let me bring up the QR code if you came into class late for the attendance. After we do the initial screening, we need to be sure to write what's your conclusion or interpretation of the IRR data. And what we see is that option K, Komatsu, should be rejected because its rate of return, its internal rate of return is less than the minimum. So our first matchup is not going to be Komatsu versus deer because Komatsu is rejected. So the first matchup is caterpillar versus deer. So option C minus option D. And in that comparison, if we look at the incremental cost and the incremental revenues and find the rate of return on the increment, we see that it's 11%. That's below the minimum. So our interpretation is keep D. So D wins the matchup of caterpillar versus deer. So that means that the next comparison is going to be H, which is Hitachi versus deer. Okay, so just to summarize, what we started with, this is basically the given data. I mean, not in so many keystrokes, like what you had, it just said annual net revenue, but it said it was for a 10-year lifespan. So you generate this cash flow table for each of the options, and we did the initial screening using internal rate of return. And that initial analysis allowed us to reject option K, so none of the incremental analyses will include option K. Over here to the right, we can see our first matchup was C versus D. And because the internal rate of return of the increment was less than the MAR, so 11% is less than 12%. So that tells us the more expensive option, here that's option C, should be rejected. And you should stick with the cheaper option. So that's why down here I said keep D, because the internal rate of return of the increment was less than the MAR, so that means choose the cheaper option. However, in the next matchup, which was H versus D, you'll notice that the internal rate of return on the increment was greater than the MAR. So because that internal rate of return on the increment's greater than the minimum, that means choose the more expensive alternative. And so Hitachi was more expensive than Deere, so that's where we transition over to keeping Hitachi as our favorite up to that point. So that means the next comparison is Hitachi versus V, which is Volvo. So Volvo versus Hitachi, $15,000 in cost. If you add up all of the revenues, that's only $7,000. That's why we got a negative internal rate of return, is that the incremental revenue is less than the cost, much less being, it's not even a positive internal rate of return. So that means we reject Volvo, keep Hitachi, and then the final matchup of Atlas versus Hitachi, we only have a 7% rate of return on the increment. That's less than the minimum. So that means stick with the less expensive of those two options. Keep Hitachi. So our overall conclusion, Hitachi is the best option. Now that's our conclusion from incremental analysis. Let me mention to you, if you did the wrong matchups, but you still just as a matter of coincidence ended up with the right analysis, I'd still have to deduct points for that. Like if you had if you had kept the Komatsu option, or if you had accidentally gone with the wrong interpretation, then you're only going to get partial credit, say like on a homework or an exam scenario. But how do we want to, like we could double check this using the NPV. So present worth analysis. Let's double check that Hitachi truly is the best alternative. So to do that, equals NPV. The rate that we'll use is the MAR, anchoring the reference there by pressing the F4 button, so it's always looking in cell B1 for the interest rate. Now for the values, I only include the amounts that are in the future, and outside of the NPV function is where I add on the cost, which is already at time 0. So we can find out the net present value of each of these alternatives, and we see that the highest net present value is the Hitachi option. So that's the one that we'd select according to present worth analysis, and that is the same conclusion we came to with incremental analysis. All right. So like I mentioned, the assignment that goes along with this concept is going to be posted on Blackboard today. Maybe while it's fresh in your mind and you already have a template file from today's in-class exercise, you should get started on that. Then the other thing, just a reminder about the project. November 17th is going to sneak up on us. It'll be here before we know it. So early effort will save you a lot of stress later on. See you Wednesday.